Okay, folks, apologies for the interruption there. Thanks for your heads up on no sound. I have no idea what happened there, but we've got sound back anyway. Apologies once again. Let's resume then. We were just talking about what we went through the last day, talking about animated drawings that we looked at, but the bulk of the class was around the if statement, and we were looking at using if statements to determine whether code should run or not. So we looked at conditional statements, and we looked at Boolean expressions, relational operators, and logic operators. And that was all part of the last day's class. We also got into mouse and detecting whether a mouse button was pressed or not, and then if it was pressed, which button was pressed. This enabled us then to create interactive drawings based on the mouse input. And we revisited again some of our operators and looked at the order of evaluation, and we gave you a quiz to work out what an expression would be evaluated to when you took account of the order of evaluation. That was basically, we did brackets first, then multiplication and division, then addition and subtraction as we work from left to right. And you had a lab on animated drawings. We also went over quite a bit of the materials that we covered in the first week to clear up some questions that were popping up on the Slack channel. On to today, quite a bit to get through in today's class. We're going to be looking at variable scope, when variables are created, how long their value lasts for, and when they're killed off. We'll also be looking at looping, and in looping we'll be looking at both the while loop and the for loop. Again, all of what we're doing is related to the steps in the lab, the exercises, and the challenges. Okay. All right. So let's get started with our slides. A couple of other things we're going to be covering along the way, which will just make life a little bit easier. And the first of those topics is the print line and the text functions in processing. By knowing about these, we can issue these commands to figure out the value of a variable. Okay, we can print them where they won't interrupt with our program, see what the values are as the programming is running, and that helps us understand what's going on. Then we'll move on to variable scope, and then compound assignment statements, which are just fancy ways of writing an assignment statement or an expression. You don't need to know them all, but it's good to be aware of them at least. So let's get started with print line and text functions in processing. If we look at print line and text, to print a message to the console in processing, we use one of two functions, print and print line. They're very similar. Print just prints whatever the value of a variable is, or a string. But then if you issue a second print statement, it'll print it right next to it on the same line. The print ln, the ln stands for line or line break. What it will do is print a string to the console, and then it'll issue a line break, which will bring you on to the next line. Both take a string as input. More on this in later lectures. And to print onto the display window, we use the text function. So we have the difference between the console and the display window. So the display window is what we've been using up to now. We've been creating different shapes on the display window. All our output has gone to the display window, and we're introducing the concept of the console today, where you can have your program running nice, creating lovely shapes, but we want to examine the value of variables. We might print those variables to a separate window called the console window, and this is common in most programming languages, to have the notion of a debug or console window. But if we want to write text itself in the same way that we create shapes on the display window, then we use the text function. So here's an example of the console in processing. We can see some code, print hello, println there. And if we look down, this is the console at the bottom. And if you can't see it at the moment, you have two tabs at the bottom, one for errors and one for console. So you can click on the console. print hello, prints hello. The println there is printing there after hello and then creates a line break. Okay. If we look at the next one, println, this is advancing the cursor onto the next line. So it prints that whole string on the next line, and because we have a println, again it prints a line break, which means that the next piece of text that gets printed to the console will start on the next line. And again we have yet another println statement, and this is also advancing the cursor to the next line. You can see that prints it on another line on its own, and again wraps around for the next thing that we print. So nothing too difficult there. Each statement prints the same output. So if we look here, we have println hello world, println hello in double quotes, plus in double quotes world. Important to note, you've got a space in here. And then the next one, println hell plus O space world. So the point here is that it's printing out this whole string, and then it goes on to the next line with the ln. But what we're doing here is something called string concatenation. We're adding two strings together, and it's a big fancy word for nothing really other than we're adding strings. Okay, string concatenation. We can use variables in the print statement. So this is where your print and println functions start becoming useful. You can see here we have a variable, int my age is given the value 20. And what's nice there is that we can now examine the value of my age by using a println statement. We're using I am, and then we're adding a variable into that string. So it's plus my age plus the years of age. And what we end up with then is the output at the bottom, I am 20 years of age. Okay, so we're combining string values with an integer variable, which gets converted to a string, added to another string, and then that gets output onto the console. So the piece to remember here is that print and println can print out the value of a variable, and we can add multiple variables together to create more complicated output or more useful output. One of the mistakes that a lot of people make, though, is they forget to put in spaces between the strings or the variables that they're adding together. So I've just highlighted those spaces there. So just if you remember that, it'll make your output nicer, easier to follow. Okay. So similar to the print and println functions, we have the text function, and text is used to draw text on the display window. If we look at this example, we can see the output here is the output window in processing. And what we're printing out is the word word 3 times. Okay. What's nice about the text function is you can specify font and font size. You can also specify color. So if we take a look, we can see text size is set to 32. Then I'm using text. I'm passing in a string, which is the word I want printed out. In this case, it's word in double quotes. And then we tell it where to print it on the XY coordinates of the output window. So we're saying X is 10 and Y is 30. So it'll print out the first word here in white. Then I'm changing the fill color. We've seen this in previous classes. We're setting the fill color to 0, 102, 153, which creates this blue. And then again, we use text word, 10, 60. So that's going to print the word, same X position, over 10, but instead now we're coming down 60 in the Y value in order to print it. And finally, we have another fill to change the color. This time we're putting in an alpha, so we haven't seen this before. We have RGB, and then we have an alpha, and the alpha represents is a word for transparency. Okay, we have alpha, which is transparency, and this says how transparent the text is. So you can see here, you can almost see the background coming through the text of the third word. Okay, so these are all examples of using the text function in processing. So we have the text to be written and the x and y coordinates where you see them on the screen. Okay, so use of the print line and text function. So maybe I'll just give you a question to do. Let's switch to Socrative. And my question is, I want you to write the line of code, please, that will put your name at position x equals to 40 and y equals 70 in order to output your name in the text in the display window in processing. Okay, so x is 40, y is 70. Display your name on the display window. And let's get that started. So I'll call the question out again. We want you to display your name on the output window or display window at position x equals 40 and y equals 70. Can you give me the line of code that you need to write in order to achieve that, please? So once again, we're asking you to give me the line of code in processing to display your name at position x equals 40 and y equals 70. And if you can do that by going to Socrative, the room name is C. Dunphy, and please put in your answer now. Okay, let's take a look at your answers. Haha, and because I asked you to put your name in, I was going to try hide your name, but of course it's now going to reveal your name. Apologies for that. So let's take a look at each of these answers in turn and see what we can all learn from the different answers. So Pat, this is great. Text. Pat Powers in double quotes, comma 40, comma 70. One little problem, you left out the semicolon at the end. Okay, so it's important that you include your semicolons so that you complete the statement. The semicolon is the end of the statement. Ian, this is fine. Perfect answer. Okay. Next we have size 40, 70, not needed. Text size 40, 7, no. Okay, so this one is not quite right. So what needs to happen here is you need to combine the 40 and the 70 are the coordinates. They have nothing to do with the size, and we actually didn't ask you to specify the size, so you don't need to do it. So it would be text, my name, and what you would need to add in there is the comma 40, 70. Okay. So I think what's happened there is you've looked at the examples we've just gone through, and you're adding in more than you're actually requested to do. Likewise here, text size 32, so that's not part of the answer. We don't need it. We just need this. Text John McCann, comma 40, 70. That's fine. Again, don't forget the semicolon. This one here, text my name 40, 70. Yeah, except put in your name. Okay. Text my name is Dermot Sheeran. Yeah, this is all fine. This one here now creates a problem. Hi Eleanor. Eleanor, it's important that you put double quotes around this piece of text, because if you don't put double quotes, it thinks Eleanor is a variable. So what it'll do is it'll print out the value of the variable. Okay, and because it has no value at the moment, that will either be blank or a 0. So you might see a 0 being printed on screen. So this is one that everybody should watch out for. You'd need double quotes around the piece of text, okay, in order to use the text. Kent, fine, and this last answer again fine, except you'd put in the actual name. Okay, that's good stuff. So that's fine for text, and print and print line shouldn't cause any trouble either. Okay, let's move on to variable scope. Variable scope. We're going to recap by looking at example 2.8 that we've already covered. You might remember it was draw a circle on the mouse XY coordinates. Each time you move the mouse, you draw a new circle. All the circles remain in the sketch until you press a mouse button. So we covered this the last day. And when you press a mouse button, the sketch is cleared and a single circle is drawn at the mouse XY coordinates. So this is one of the lab exercises that you should have completed at our last class. And if we take a look at the code here, we can see nothing too amazing. We've got the setup and draw routines. Setup code runs once, remember. The draw routine runs many times per second. We have size, setting up the output window. Background 0, changing the background to black. And then stroke is 255, making the white stroke, and the fill then is set to a grey colour. So what's happening? 60 times a second we call the draw function, and in there we have a test to test if the mouse is pressed. So we're checking this system variable called mouse pressed, and if it returns true, then we will clear the screen by using the command or function called background 0, and this will just make the background black again. The alternative then, or sorry, let's go through that again. If mouse press is true, it clears the screen, and that's the only time that it clears the screen. But every time we come in to draw, it's going to run the ellipse in order to draw the circle with 100 diameter at the current mouse XY coordinates. Okay, so again, we went through that the last day. What we're trying to highlight here is that the 100 and the 100 here are hard-coded values, okay, for the diameter of the circle. And we started introducing variables over the last couple of classes, so what we'd ideally like to do is to try and remove hard-coded values where possible from the detail of our functions and put in variables instead. So we might do something like this. Here we've replaced the hard-coded 100 with a variable diameter whose value is 100. So why is that? Let's take a look. We have in the setup routine is still the same. The draw routine is still the same, but we've declared this new variable called diameter, which is an integer value, and we're setting it to 100. And then, because we now have a variable that has the number 100 stored in it, we can, anywhere where we previously had 100, we could use that variable. So our call to ellipse is now mouse x, mouse y, comma, diameter, comma, diameter. Okay, so this issue, or this program, is going to highlight the reason why we need to understand the scope of a variable. So let's talk about local scope. The diameter variable is declared in the draw function. In other words, it's a local variable. It is local to the draw function and is only alive while the draw function is running. So if we take a look at the draw function, we can see that we've declared the integer variable diameter here. So it gets created every time draw runs. And then we do what we did previously, drawing the circle at the current xy value, which has a diameter of 100. So each time the draw function finishes running, the diameter variable gets destroyed. Okay, each time the draw function is called, the diameter variable is recreated. So in other words, this line of code creates a new variable called diameter. We can use that variable throughout the function, but when the function exits, in other words, once it's completed everything, what it does then is it deletes or destroys this variable diameter from memory. So our program no longer knows about diameter when the draw function completes. The scope of a local variable is the block it's declared in, and a block is delimited by curly braces. A program can have many nested blocks. So here's some code. So you'll notice that we have a variable number, which is declared as an integer. We're giving it a value, some random value between 0 and 39. Using a call to the built-in processing random function. Might be worth making a note of that for future use. Random 40 gives you a number between 0 and 39 when you convert it to an integer. But this variable number is in the outer block of the program. In other words, the first level of code that you start writing. And what we said is a block is delimited by curly braces. So you can see I've got curly braces with my if statement. So I can declare a variable inside the curly braces, which means that they are created inside the curly braces, but outside of the curly braces those variables get destroyed. So in this code fragment we can see that we have if number is less than 10, and then we have curly braces for the if statement, so that creates a block, and inside that block I'm declaring the variable j. We also have an else if, and in the else if block we declare a variable x. So j is only created if the number is less than 10, and x is only created if it's not less than 10. The lifetime of a local variable is the time of execution of the block it is declared in. Trying to access a local variable outside its scope will trigger a syntax error. So let's take a look at this. Code looks fine. We have a draw function. We're saying if mouse pressed, then declare the diameter variable. The diameter variable in this case is 10. Sorry, is 100. Now, if the mouse is pressed, it will declare the variable diameter, give it an initial value of 100, and then change the background to black. Okay, but as soon as we hit this final curly brace, the variable diameter no longer exists because it's now out of scope. So when we come down to write the next line of code, we're trying to access a variable diameter which no longer exists because it has been destroyed at the end of the block, and the block here was the curly braces. So this is going to result in a syntax error. Okay, in other words, you've done something that you should not have done. You're using a variable that's not available to you. Okay, in other words, your variable is now out of scope. Okay, it doesn't exist anymore. So that's what we mean by scope. So let's move it on a little bit. Using our 2.9 code, we now want to reduce the diameter size by 10 each time the mouse is pressed. So if we take a look at our draw function, we've set a variable called diameter, initializing it to 100, and then we're using that variable in the ellipse call, where we're substituted the two 100 values for the diameter. This is the example 2.9 that we looked at a few minutes ago. And what we want to do is we want to reduce the diameter. So every time we draw a circle, we want the circle to get smaller. And one way of doing that would be to leave the ellipse call as it is, but to change the value of diameter. So what we're seeing here is if the mouse is pressed, we're reducing the diameter by 10, subtracting 10 every time. So we have a bug in our logic. As the diameter variable is recreated each time draw is called, its value will be reset to 100. So let me explain why. Every time draw gets called, it's getting called 60 times a second, you might remember. And every time we come in, we create this new variable called diameter, and we set it to 100. Then we're saying when I press the mouse, subtract 10 from it to make the diameter smaller. The problem is, this is happening 60 times a second. So it's going to come out of the draw method and come back in and change diameter to 100 again. So before it ever gets to draw a circle, okay, it draws a circle, and before it ever gets to make use of this reduced value of the diameter, we are calling draw again and setting it to 100. Okay, so it might be an idea at this stage, I think, to give you the code here. I'm going to post the code in Slack, and I'm going to ask you to run it in your processing environment. And what you'll see is, although it looks like it should work, it doesn't quite work. So let's do that. So I'm just going to share some code with you. Let's put that into Slack. So what I'd like you to do is take the code that I've just shared, open it up in your processing environment, and I can do the same here. And I'd like you to run this. Let's try again. So we're going to include the code. And if we run it, we can see that although we've tried to make the diameter get smaller, it's not actually getting smaller. So every time I click the mouse, It's supposed to make the diameter smaller. Okay, but it doesn't quite do that. So let's see if we can get to the hub of why that is. So again, it's got to do with the scope of the variable called diameter. So let's take a little run at it again. The scope of the diameter variable is too narrow. As soon as draw finishes running, the local variable gets destroyed and we lose all its data. In other words, although we decremented it by 10, making it 90, as soon as draw finishes, we have no variable called diameter. Then draw gets called again, and the first thing it does is it creates a new variable called diameter and sets its value to 100. So we're constantly starting with a variable set to 100. So we need a variable called diameter that lives for the lifetime of the sketch. In other words, we need to use something called a global variable. Again, it would be a good idea to make a note of global variable at this stage. So let's see how that changes our code from the previous version. You might remember in the last class I showed you that the numbers that we're using on the slides correspond to the steps that we're using in the lab exercises. So by following this through, you're actually doing the lab. Okay, so this is example 211. And we're trying to fix this bug so that we can make the diameter reduce in size. We established that the scope of the local diameter variable was too narrow. The diameter is recreated each time draw is called and its value is reset to 100. So what we could do is we could comment out that line of code that declares the diameter variable inside draw, and instead of declaring it inside draw, we declare it globally. And it's good practice or normal practice to declare your global variables at the top of your program. And we can see here is where we're declaring the variable. The code to declare the variable is exactly the same. We're declaring a variable int diameter equals 100. It's exactly the same as we had before, but the location and the positioning of it is what's different. When we declare a variable inside curly braces, you might remember we said the scope of that variable is just inside those curly braces. So if we don't have it inside any curly braces at all, then it means we can use that variable in any function, in any if statement, in any loop. Okay, it's available everywhere. And when we refer to variables that we can change everywhere, they're called global variables. Okay? So the diameter value is decreased each time we press the mouse. However, what happens when the mouse pressing reduces the value of the diameter to 0? Okay, so what we've done is we've got a program running now that will reduce every time. Let's take a look at it. Let's bring up processing again. So this is the code that we had a second ago, and all I'm doing is I'm going to take this line of code, I'm going to comment it out so it no longer runs in draw. I'm going to go up to the top of the program and paste it in. So now we've got diameter declared as a global variable at the top of our program. So now when I run the code, you can see it's still drawing the circle with 100, but if I click, every time I click, the circle gets smaller, but we've introduced a new problem. It's now getting bigger and bigger and bigger, even though we've said subtract, and now you can't even see it drawing the circles. Let me run that again to demonstrate. So I've got a circle 100, I click and the circle gets smaller, press the mouse button again, gets smaller, press it again, gets smaller, but it gets so small that then it starts getting bigger again. and it will keep getting bigger. So let's go back and take a look at our code. So the logic was, draw is called 60 times a second, and we said if the mouse is pressed, we're going to subtract 10 from the diameter. Okay, so we start with 100, then it becomes 90, 80, 70, 60, 50, 40, 30, 20, 10, then we subtract 10 and it becomes 0. But then we subtract 10 again and it becomes minus 10, then minus 20, minus 30, minus 40, and so on. However, what we are learning about ellipse is that the value that you pass in, it ignores the sign, so it only takes the magnitude of the number. So whether you pass in 10 or minus 10, it will just draw a circle with a diameter of 10. Okay? And we refer to that as being an absolute value. So let's see what we said about that in our notes. Okay. So what you're seeing on the slides here is the example of the program that I just ran. We can see that the diameter variable is decreased as we press the mouse, so it gets smaller and smaller and smaller. However, when it reaches 0, the diameter of the circle starts growing again. We see it getting bigger and bigger. Okay. The width and the height in the ellipse function are absolute values. And what that absolute means is that the negative sign, the minus sign, is dropped from the number. So even though the diameter had a value of, say, minus 50, the magnitude is all that is used when drawing the ellipse. In other words, minus 50 becomes plus 50 for the purposes of the ellipse function. Okay? So now that we know about that, we can handle that situation using an if statement. So in the ellipse function, the width and height are absolute values. The negative sign is dropped. To handle this logic bug, and it is a logic bug, a logic error, we need to reduce or stop reducing the diameter by 10 when we reach a certain value. So there's no point in drawing a circle of width 0 because that doesn't show anything on screen. I'm just distracted by a comment. Let's take a look at the comment. Silly question, but why did it only take a few mouse clicks to get into the minus values and the code is only reducing by 10 per time? It's not a silly question, it's a great question. Is it something to do with the refresh 60 times per second? Ian, thanks for that. Exactly, that's exactly what's going on. It's happening so quickly that you're not seeing it drawing the smaller circles. Now if you try click on your mouse button quicker, in other words, don't hold down the mouse button for a long time, just click it really quick, you'll see it draw more circles. But you've hit the nail on the head. It's to do with the 60 times a second. Okay, so you don't actually see it drawing all of them. So one of the things we're going to look at later in class is how do we reduce the frame rate so that we can actually see it and slow things down so that we can see it reducing properly. Okay, good question. And there are no silly questions. Okay, so that applies to everybody else. Thanks for that. Okay, so we were just talking about the logic bug. We need to stop reducing the diameter by 10 when we reach a certain value. Let's look at how we might do that. We add to the code that we had in 211. We're going to add double ampersands. So we're now testing some logic. We're saying if the mouse is pressed and the diameter is greater than 20, then you subtract 10 from the diameter. Okay, so we're only going to do it until it reduces down to the smallest size. That way you'll see a circle that's of size 10 in diameter. So when you run this code, it appears the reduction is larger than 10 when we press the mouse. So this is your question, Ian. Thanks for that. Why? The default frame rate is 60 refreshes of the screen per second, i.e. draw is called 60 times a second. You can change the frame rate by calling the frame rate function. Again, if you're watching this back or watching it live, good idea at this stage to make a note of the frame rate function. So we had the random function earlier in class, we now have the frame rate function, and you want to make a collection of all these function calls so that you can use them when you're writing your own programs. Okay. So here's where we're changing the frame rate. So we're going to slow down the frame rate to 20 so that you can see it drawing those reduced circles and getting each increment or each decrement. Okay. So I think what I'll do is maybe ask you at this stage to make that change to your code. We want to get you to follow this as we're doing it. So here's processing. We're going to modify what we just had. We said if the mouse is pressed, but we also had and if you could do this with me, it would be great. You'd have some of the steps for your labs completed. If mouse pressed and what did we say? We said the diameter is greater than 20. So the diameter is greater than 20. Okay, did I spell that right? D-I-A-M-E-T, left out the E. Okay, so we're only going to draw the circles and decrement it by 10 if the mouse is pressed and also the diameter is greater than 20. Now notice when I put in this ampersand diameter greater than 20, I now need to also put the outer brackets for the if statement. Okay, so if brackets, and then inside the brackets is what's your condition. Okay, so I'm putting those outer brackets in there. The other thing we wanted to do was to include the frame rate. So we're going to change the frame rate in the setup. Camel case, frame rate 20. There we go. And let's run it and see what happens this time. So the program should do exactly the same thing, except we can actually see more of the changes. And then when we get down to the smallest size, you notice that it's not getting any smaller, it's also not getting any bigger. Okay, so what happened there was we said we're only going to make the diameter 10 less if the mouse button is pressed and the diameter is greater than 20. And in order to be able to see more of the values changing, we slow down the frame rate. And you can change that to whatever rate you like. So for example, if I change it to 10 and run it again, you can see what's happening. By slowing down the frame rate, you can actually see more of the different changes in the diameter. Again, once we get down to a minimum size, no matter what I do, it's going to leave the circle at that size. Okay, so what we're doing here is we're looking at logic. We're combining all of the arithmetic and Boolean logic functions that we looked at the last day and operators, and we're combining them with our if statement, the condition statement that we looked at the last day, to make our programs run. Okay. So that's our variable scope. We're going to take a break after this one. We've got a couple of more slide decks to get through, but we'll take a break after we go through compound assignment statements, because that won't take us too long. Okay, so let's take a look at these. The last day we looked at the arithmetic operators, plus, minus, multiplication and division. And now we also looked at assignment statement, which we said was a variable and then the equal sign, but the equals doesn't mean equals, it means assignment. So here we're saying x is assigned a value x plus a. Okay, so we're happy with what that does. We've just completed an example where we said diameter is assigned a value diameter minus 10. So this is an example of that. Okay. And if we maybe start with that example, another way of saying diameter is assigned a value diameter minus a is to say diameter minus equals a. So this is like a shorthand way of writing an assignment statement, and we call these compound assignment statements. So what you'll notice is for the plus, minus, multiplication and division, you'll see that instead of saying variable is assigned a value variable with the operator and then some other value, you can just say variable, the operator, assignment, and then the value that you want to either add, subtract, multiply or divide by. Now we will use the first two quite regularly. We tend not to use the multiplication and division very often, but they are available to you. We use the next two quite a lot. So if we want to just add 1 to a variable, we say x plus plus, variable plus plus. If we want to subtract or decrement, instead of saying x is assigned a value x minus 1, we'd use x minus minus. Okay, so these are called compound assignment statements, and even if you don't think you would like to use them, you're going to need to know them because you're going to have to read other code, and these are used quite a lot. I would say the bottom two are the ones that are used the most, then the plus assignment, and then the minus assignment. Multiplication and division not so often, okay, but they are there. So these are compound assignment statements. Okay, so let's give you a question. Let's launch another question. Okay. So the question is, give me a shorthand way of incrementing the variable y. So let's get you to do that in Socrative. And we'll switch over. So I want you to increment the variable y. What would the line of code be to add 1 to the variable y? Shorthand code, please. Okay, cool. Let's take a look at your answers. Almost a clean sweep. So we had y plus plus. Excellent. Don't forget the semicolons. They're going to give you trouble. Okay, so if you've left out the semicolon there, make a note to yourself. Semicolon is the end of a statement. So you write your statement, but you finish it with a semicolon. So a couple you need to make changes there. Also, this one is incorrect. Y assigned a value plus plus. No, it's y plus plus. Okay. The assignment here would again generate a syntax error. Let's try another one. So this time, what we'd like you to do is give me the shorthand for adding 15 to the variable r. forgot to hide the answers. Apologies. Okay, let's take a look. So R plus equals 15. Semicolon missing on this one, so don't forget that. And here we have R plus 15. No, that's not going to store an additional 15 in the variable R. You need to R plus equals 15, okay? And these are all fine too. We just put spaces between them. You can do that. Although you can't put a space between the plus and the equals. Okay, they need to be together. But this one here is fine. Okay, well done everybody. Let's try one more. Let's finish that. Oh. Let's just launch one more for you this time. Let's get you to store 25 less in the variable total. So we're storing 25 less in the variable called total. Okay, answers are in. Let's take a look. Good. I think we're all on the right track now. We got a clean sweep that time. Well done everybody. Total minus equals 25 semicolon. So remember the semicolons are important, but well done. Everybody got that one right. I think. Yeah, we get a late entry. We did. Okay. So now that you all got all the answers right, I'm feeling good. Let's take a little breather. We'll have our convenience break now. We'll be back in 5 minutes. Any questions, you can ask them on Slack. Okay, welcome back. Let's crack on. What we're going to look at next is loops, specifically loops called while loops. But we'll look at the other ones initially, take a little loop at them. We'll cover while and for loops before the end of class today, and the others we'll be looking at in a later class. Okay, so let's get cracking. So when we talk about loops, we're talking about repetition, and repetition in programming is something that we use computers for. It makes life a lot easier because we don't have to keep repeatedly doing the same task or writing out the same equation. If we can write things in a certain way, we can make them repeat over and over again. So we're going to be introducing looping, and then we'll move on specifically to different types of loops in processing. So let's start with an intro to looping. Let's look back first at Boolean conditions, because in our loops we're going to be using extensively the Boolean conditions. So a Boolean condition is an expression that evaluates to either true or false. For example, mouse x less than 50. Is mouse x less than 50? Well, if the current position of the mouse pointer is to the left hand side of the screen, it would be. So it would be true, otherwise it would result in a false. Boolean conditions can be used to control selection, i.e. the if statement, and also iteration, i.e. loops. We will look at these now. Okay. So computers are very good at repetition. For example, we could calculate the pay for 1,000 employees. You should use the same calculate pay algorithm 1,000 times. You don't write the calculate pay algorithm 1,000 times. Instead, you include it in a loop. We could draw a rectangle 4 times that has a gap of 10 pixels between each one. So if we weren't using loops, we'd have to write 4 lines of code like this. Okay, so here we see rectangle. We pass in the x and y coordinates of the top left of the rectangle, and then we pass in the width and then the height. So x and y is 50 and 60, the width and height 510. Because we want to draw the same loop every time, we're seeing that the last 2 parameters are the same for each one of these statements. Because we always want to start underneath the previous rectangle, as we see here, each rectangle starts in the same position and ends in the same position. That's why the first parameter is always the same. The one that's changing every time is the y value, and that's because we need to create the first rectangle here, then the second one drops down a bit, third one drops down, fourth one drops down, and we've got an equal gap between them all. So that's achieved by adding some number to each one of the subsequent calls. So if we started with 60 and we added 20, we get 80, and we added 20 again, we get 100, and add 20 again, we get 120. So we have the notion of a gap, the gap being consistent between each of the squares. And again, we saw this example program in an earlier class. So that's how you do it without a loop. With a loop, you might consider something like this. We draw a rectangle 4 times that has a gap of 10 pixels between each one. So what we would see is call to the rectangle function the x and y coordinate, and then the width and the height. So the width and the height is always 10. So if we want a gap of 10, we'd have to add 10 and 10 together, giving us 20 in order to start the next rectangle. So adding 20 onto the y coordinate variable each time with this line of code as a starting point would give us a more efficient way of writing the program. We'll learn more about loops and then we will write the code to solve this exact problem. So let's take a look at loops then in our code. There are 3 types of loop in Java programming. We have while, for, and we also have do while. And we'll focus on the first 2. The difference, and I'll point it out at this stage, the difference between the while and the do while is the while loop may never enter the loop, whereas do while will always execute the loop once. Don't worry about that, we'll be revisiting it later. We also have something called for loops. So let's take a look at our while loop to get started with first. So what we have is some pseudocode here. Pseudocode is code that you can't run, but it helps us highlight what needs to go into the code. So here we have while loop condition in brackets or parentheses. We have curly brackets is the statement to be executed as part of the loop, and the loop body are the actual statements that you write. So this is the generic or general form of a while loop. So it's the while keyword, Boolean condition, statements to be repeated, and this enables us to write a loop. So if we want to construct a while loop, we declare and initialize the loop control variable. Again, might be an idea to just make a note of this. LCV is shorthand for loop control variable. So we declare a variable first, then we have a while statement with, let's put on this thing, we have a while with a bracket. Inside we have a Boolean condition, and the condition is based on or will include the loop control variable. Then what's the job you want to repeat? So you'd have that inside, and then the last statement in the loop or the body of the loop will be you'll need to change the loop control variable in some way. So usually that's adding a value, incrementing or decrementing. So this is the structure for a while loop. Here we have something called a flow chart. Let's take a look at what we mean. We declare the variable I, which is our loop control variable. We're setting it to an initial value of 0, and then we have a while condition, while I is less than 4. So what we would do is we would test this condition. Is I less than 4? Well, 0 is less than 4, so it's true. So what we do is we go to the true branch and we execute the statements inside the curly brackets. So here's the curly brackets. These are the statements inside. So I execute those, and what that does is it's going to draw a rectangle at the current y coordinate, and the y coordinate is up here, a global variable set at 60. What we do at that stage is we change the value of the y coordinate and we add 20 to it. So that gives us the y coordinate of the next rectangle that we want to draw. Then we increment I. In other words, I gets the value of I plus 1. So I is 0 plus 1. It's now 1. So we've executed our statements. We come back around the loop and we test the condition, the Boolean condition. And the condition is I less than 4? Now I is currently 1. We're testing is 1 less than 4. It is. So we come in here and we draw the second rectangle. Then we update the y coordinate and we increment I. So the y coordinate is now 60 plus 20 is 80. And that was after we drew the first rectangle. Draw the second one, it becomes 100. And I is now 1. Again, we've executed our statements, we come back around the loop and we look at our Boolean condition again. So is 2 less than 4? Yes, it is. We execute our statements, back up around. Is 3 less than 4? Yes, it is. Execute our statements, back up around. Is 4 less than 4? No, it's not. So now we go to the false part. So if we take a look here, that means we're exiting out of the loop and there's nothing else to do. So we now have our 4 rectangles drawn. So that's what we mean by a flow chart. Let's take a look at example 213 in your lab. Here we've got the y coordinate is set at 60, size, background, fill, no stroke, nothing new there. But here's now how we're going to sort out our loop. we said, could we remove the y coordinate variable and rework the code to still produce 4 lines using the while loop? So, just before we answer that question, let's take a look at what's happening in the loop here. Might just change this to pen. So we have our loop control variable, or LCV. We're setting I to 0. We have our while loop while I is less than 4. Rectangle, draw a rectangle using the value of the y coordinate. The y coordinate is up here at 60. So effectively what happens is we draw a rectangle at 60, and I'm just going to keep track of I here. So currently I is 0. Let's run through this. We draw a rectangle at 50, 60, 510. So what that does is it draws this first rectangle here. We then change the y coordinate to be y coordinate plus equals 20. Y coordinate is 60 plus equals 20 makes it 80. Actually, let's just step back there. I'll do the y coordinate over here so you can see it. Apologies, I'm just writing with a mouse today, so hopefully you can read my writing. So initially we have 0 and 60, then we change the y coordinate so it becomes 80. Then we have I++, so that's going to add 1. So the I becomes number 1. So we've drawn one rectangle, and then we've updated the values of I and the y coordinate. We come back around our loop and we test I less than 4. I is still less than 4 because I is 1, so that means we're going to now step inside and do what's inside the loop. And when we step inside the loop, it tells us draw a rectangle at 50, and the current value of the y coordinate is 80, so it's going to draw 50, 80, 510. In other words, it's going to draw the second rectangle. Then we're going to update the values of the y coordinate to be y plus equals 20, which makes that now 100. And I gets updated to be I++, which is 2. Come back up around the loop. While I is less than 4, is 2 less than 4? Yes, it is. So we come back in and draw the third rectangle. So here's our third rectangle. Third rectangle was the 50 and the current value of the y coordinate, which is now 100. So that's why it draws the third rectangle where it does. We then update the values for the y coordinate. Adding 20 to it makes it 120. And we update I to be I++, so it's now 3. So our y coordinate now has the value of 120, and I is 1. So I is 3. Come back around the loop. Is 3 less than 4? Yes, it is. So we now again come in and execute this rectangle statement. So it runs 50, 120, 510, drawing the fourth rectangle. And then we update y coordinate and I again. So y coordinate becomes 140. And I gets incremented to 4. Then we come back up around the loop and we test is while I, which is now 4, less than 4. At this stage 4 is not less than 4, so the condition fails, so we don't implement the contents of the loop. We exit the loop and we start running any lines of code from line 15 on. Okay, so that's how our code operates. That's what we've just been highlighting with a while loop. That's how our while loop runs. Hopefully you're all finding that okay. So the question we have is, could we remove the y coordinate variable and rework the code to still produce the 4 lines using the while loop? In other words, can we make this program a little bit more efficient? So if you look at it, we are changing two variables. We're changing y coordinate and we're also changing I. And if we were a little bit more clever about how we write the code, we could definitely get rid of one of those variables. So here's the solution. So what we've done is we've taken away the y coordinate variable from the last example, and we're going to use the loop counter variable to do the same job. So this time we're starting with, while I is less than 120, draw the rectangle using the I value, and instead of just adding 1 every time, we're adding 20 every time to the variable I. So the 3 stars here are highlighting what's changed from the previous example. Okay, so previously we used two variables, y coordinate and I, and now we're just using I. Okay, so you'll have to study that in your own time to get comfortable with it. There are two ways of doing exactly the same thing. The output for both programs is the same, just one is more efficient than the other, and that's something we'll develop over time. Also, some additional exercises to try out with the while loop. The basic while loop produces this output. Here we're using the print line function that we looked at earlier in class, and we've got some additional questions for you to try in your own time. Okay, so change the code so that hello world is printed out 10 times. Change the code so that the numbers from 1 to 10 are also printed out. And change the code so that the numbers from 10 to 1 are printed out. In other words, you're going to go backwards. How would that affect the code that you write? Okay, so that's while loops. We've got a little bit more time, so we'll push on with the final slide deck. We won't get through all of this in today's class, but we'll get started on it, and we'll pick it up the next day. Okay, so we've just looked at while loops, and what we're now going to do is take a look at for loops, and this is just another way of achieving the same result in code. There's usually more than one way of writing a program, so this is another way of writing loops. So let's take a look at our topics list here. There are 3 types of loops in programming. We have while, for, and do while, which we've already mentioned, and we've gone through the while loops, counter-controlled n times, in the previous talk. We'll be looking at sentinel and flag-based loops in a later class. Don't worry about that for the moment, but I want to get you on to for loops. And again, we'll cover do while later. I'm not going to have time to get through the challenges. And again, the challenges are not something that everybody needs to complete every week, but I have given you some notes to help you out with the challenge in this slide deck. So let's see if we can get through for loops. So here's the pseudocode for loop. We have the change this. We have the for keyword, we have open bracket, and then we have 3 components. We have an initialization, a Boolean condition, and a post body action inside a closing bracket. And then just like with the while loop, the statements that need to be repeated go inside. Okay, so this is basically another way of writing a while loop, but we're putting all of the different sections of the while loop inside in this header of the for. Okay, it'll become clearer as we see an example. So this was a slide from the previous talk. We used a while loop to repeatedly print 4 rectangles to the display window. The example that I walked through and wrote out all the values for. So we've just covered that. This code does the same as the previous slide, except that we use a different loop. So if we just jump back here, with the while loop we had to have an initialization, which we see here. So this was the initialization of the loop counter variable. Then we had the condition, Boolean condition, And then we have the loop counter increment. So if you just look at those three components, initializing the loop counter variable, testing the loop counter variable to see does it meet a condition, and then incrementing it, the for loop should become a lot easier to understand. So here we have the initialization, here we have the test of the condition, and here we have the increment. We're just putting them all in one place. It's a different way of writing the loop, and we call this type of loop a for loop. And then the code that you want to repeat every time goes inside the curly brackets. So again, if we break that out, we have the I is the initialization, setting that to 0, declaring the variable and setting it to some initial value. Then we have the test condition every time we go around the loop, and then we have the post body action, or incrementing the loop counter variable. Then we have the statements to be repeated inside curly brackets. Okay, so that's the for loop syntax. Again, this just breaks it out, explaining what each one is. We're initializing the loop control variable, can include a variable declaration. The Boolean condition is a valid Boolean condition that typically tests the loop control variable, and then the post body action is a change to the loop control variable contained in an assignment statement. Similar flow chart as we had with the while loop. And here we have example 215 again, and we're asking the question, do we need the y coordinate variable? Can you think of a different approach using a for loop? So just as we did with the while loop, instead of using the y coordinate variable, we were able to remove the y coordinate variable, and we can do the same when we use the for loop. So if we change the values of I, so we make I start at 60, we keep going while you're less than or equal to 120, and every time we go around the loop we're incrementing by 20 the variable I. That means we can get rid of that y coordinate variable and just use the loop counter variable instead. Okay. So this is an extreme example. This is a for loop which is called an infinite loop. Sometimes if you get the logic wrong in the code that you write, you can get your program stuck in an infinite loop. An infinite loop means it's constantly testing a condition that will never fail, so it's constantly in the loop. Okay, so it's an infinite loop, and you may need to break out of your program if that happens. So an infinite loop is not something we're looking for. We had nested if statements in a previous talk. You can also have nested loop statements. So you can have a loop within a loop, and this is an example showing an outer loop which uses the variable I, and an inner loop using the variable j, and we can see then all the values that are printed out by running a loop within a loop. Okay. Again, you would want to take some time to take a look at that example after class. So it's a nested loop, a for loop inside a for loop. Okay, we're just up on 2 o'clock, so I think it's time to sign off. The remainder of the slides in today's class are to do with the challenges, so they're not necessarily something we need to go through in the talks, but you might find it useful when you're working through the labs to have a look at those challenges. Okay. If we have any questions, you can ask those questions on Slack, but otherwise let's get you to just do an exit poll, and we'll talk to you again. Eamon will talk to you tomorrow for web development, and I'll talk to you again next week. Okay, so let's get you to do an exit ticket, please, and we'll talk to you again shortly. That's the end of today's class. let's give you that exit question. The exit question is, what was the most challenging topic that we covered today? What was the bit that you maybe had trouble with that you might need further clarification on? Okay, if there was any example I did or any topic that I covered that you need more help with, maybe highlight which one that is.